Path analysis and structural equation modeling, SEM, are both statistical techniques used to analyze relationships among variables, but they differ in scope and complexity. Here are the key differences between the two. 1. Scope and purpose. Path analysis primarily focuses on analyzing the direct and indirect effects among variables in a hypothesized causal model. It deals with a single level of analysis, examining relationships between observed variables. Structural equation modeling, SEM, encompasses path analysis as well as additional capabilities. SEM can handle multiple levels of analysis, latent variables, measurement error, and complex models involving both observed and latent variables. It is used for testing and validating theoretical models and hypotheses. 2. Model complexity. Path analysis typically involves simpler models with only observed variables and direct relationships specified between them. It does not allow for the inclusion of latent variables or measurement error. SEM allows for the inclusion of latent variables, unobserved constructs, measurement error, multiple indicators for each latent variable, and complex relationships among variables. SEM can represent more nuanced and realistic models compared to path analysis. 3. Estimation method. Path analysis generally relies on methods like ordinary least squares, OLS, regression, or maximum likelihood estimation to estimate the parameters of the model. SEM also uses methods like maximum likelihood estimation, but it can handle more complex situations where variables may not meet the assumptions of OLS regression, such as non-normality or non-independence of observations. 4. Model assessment. Path analysis evaluates model fit using statistics such as the chi-square test, goodness of fit index, GFI, and root mean square error of approximation, RMSEA. SEM provides a wider range of fit indices including the comparative fit index, CFI, Tucker-Lewis index, TLI, and standardized root mean square residual, SRMR. SEM also allows for model modification indices to improve model fit. 5. Software support. Path analysis can be conducted using software packages that support regression analysis, such as SPSS, SAS, or R. SEM requires specialized SEM software packages such as Amos, Lizrel, M+, or Lavon in R. Example 1. Path analysis. Suppose you are interested in understanding the factors influencing students' academic performance. You hypothesize that parental involvement, time spent studying, and socioeconomic status directly influence academic performance. You collect data on these variables from a sample of students and their parents. In path analysis, you would construct a model like this: parental involvement, academic performance, time spent studying, academic performance, socioeconomic status, academic performance. You would then estimate the direct effects of parental involvement, time spent studying, and socioeconomic status on academic performance using regression analysis or similar methods. Example 2. Structural equation modeling, SEM. Now let's extend the previous example to include latent variables and measurement error. Instead of directly observing parental involvement, we consider it as a latent variable measured by indicators such as frequency of parent-teacher meetings, help with homework, etc. Similarly, academic performance is a latent variable measured by exam scores, GPA, etc. In SEM, the model becomes more complex. Latent variable, parental involvement, academic performance. Latent variable, time spent studying. Academic performance, latent variable, socioeconomic status. Academic performance. Additionally, you might include measurement error for observed variables and correlations between the latent variables. SEM software would estimate the relationships between the latent variables and observed indicators simultaneously, accounting for measurement error and allowing for the examination of indirect effects and model fit indices.